Okay, and now we're recording, and let me not forget to share my screen. Where's the sharing screen button? There we go. And okay, I'm ready to start. So again, today, just a midterm review for questions that people have. And let's see, so last time at the end of class, Julie had a really great question about going over the row overhead quiz, and in particular, the last problem. So we'll start off today going over all the things that you need for this problem, basically reviewing everything about the row overhead stuff. My suspicion is that this is probably the area of the midterm that people feel the least comfortable with, because the Pagilla problems, they're easy to sort of run and get quick feedback with Postgres about whether you're doing it right or not. And these are a little bit more, I guess once you have all the details down, they're not hard, but there's a lot of details to get down, and there's no necessarily automatic way to check your understanding. So we'll go over this as our first sort of content thing. But before we do that, are there any questions about the administrative aspect of the exam? What to expect format-wise or rules-wise? Question, Karen?
So we just like on the repo and then we submit the link.
Yeah, exactly. So right now, I have still the old midterm posted. Sometime this afternoon after office hours. So you'll still have office hours available to come and ask any questions you'd like. And then after office hours, I will post in this repo a new midterm, and I'll make an announcement on GitHub issues when I do that. And the instructions are going to be exactly the same, with the exception of different due dates and different point totals for problems. But basically, you'll fork this repo, complete everything in this SQL folder. There'll be 5 problems listed here. And the first 4 of these problems are going to be just like the Pagilla problems. And then the last one is going to be somehow related to the column Tetris. And again, I'm going to grade all of these manually, looking through it and using my own judgment to see whether you adequately answered the problem or not. There's not going to be any automatic grading on the midterm here. And so the main difference is going to be the collaboration policy, that not allowed to work with another human being on this assignment or post questions anywhere on the internet. But you are allowed to use any resources you'd like. You're encouraged to use Postgres, opening it up in Docker and running it, and checking all your commands that way. Encouraged to reference the previous assignments, the class notes, and any other online references, and so on. Again, instructions. So you're forking this repository, answering the problems, committing your changes, and then submitting a link to Sakai. Did that answer your question, Kieran?
Is there an answer key for last year's midterm?
Question is there an answer key for last year's midterm? The answer is there's not. But these problems actually made it into your homework assignments. I deleted some old homework assignments and put these ones in. So you've seen these problems, all these problems before. And speaking of, I guess, answer keys, I don't think I mentioned this before, or I did mention it for the Pagilla homework, that there is a solution branch now, but the other Pagilla homework 2 and homework 3 also have a solution branch. If you just want to see what my solution looks like on those problems, you're welcome to do that. And there is, again, a sort of style points for writing your SQL code. There's no like specific format that I'm looking for on the SQL code, other than that it's just like moderately reasonable, as long as I can look at it and like understand what's going on without having to edit things myself, then you're not going to lose points. But you can lose up to 3 points style-wise if like you have everything just on one line and I just can't understand what's going on. Sorry?
Do you care about putting like keywords in all caps?
I don't care about putting keywords in all caps or not all caps. Either way is fine. Let's see. My main recommendation is that when you're selecting things, just have each column be on a different line. That makes it easy for me to count how many columns that you're looking at, exactly what the columns are, and making sure that I won't miss something that way. And similarly, when you're joining things, have each table that you're joining with be on a different line. And there's a number of ways to format that's reasonable, and any of those are fine. Basically, as long as my eyes are not bleeding while I'm reading your things, then you're not going to lose points. But yes, you can always look at my code, follow that sort of the style. Any of the styles that I've used in class will all be fine. Good questions. Any other questions about anything admin-wise before we get into content-wise? Yes. Okay, that should be posted. I might have forgotten to push it. Either remind me right after class or post an issue, and that'll make sure that I do that. Good questions. Any other admin things before we get to content things? Okay, so starting off with this problem number 3 here in the what would have been a quiz, but ended up being the take-home exercise that everybody got full credit on. Number 1 and problems number 1 and 2 are basically just, they're shorter versions, smaller tables, fewer things. So easier versions of problem 3. They're not testing anything different there. And so one of the weird things, maybe, or the first weird thing about problem 3 is there's a lot of variable types that we never covered in class at all. So in particular, things like this TS vector down here, we never talked about that. There's this public.year thing. We never talked about that in class. Numeric, I might have mentioned it, but we didn't actually use it when we were doing column Tetris or anything like that. So I want to real quickly review how for any particular type to find out what its alignment and what its size is. So the main tool that you'll want to use that, or that you'll want to use for doing that, is Postgres. And so here I'm just in the Pagilla homework 2. Going to be the same if you're in the midterm one. They're all going to be using the same schema files, SQL files. And so now that I'm in here, there was a query that I gave you that looks something like this, selecting the type name, type line, and type length from PG type. Again, PG type is a relation or table built into Postgres that has all the information about the types inside of it. And I do that, and we get this huge, giant list of 661 different types. And so I press Shift-G to go to the bottom, lowercase g to go to the top. This is the pager environment again, and the pager environment uses the same hotkeys as Vim. All of these sort of Vim-style hotkeys, they sort of are in use in many, many locations in different programs, because everybody is supposed to know how Vim works, supposed to know the Vim hotkeys. And so when people need hotkeys for their other programs, they just copy Vim hotkeys. So Shift-G takes you to the end of the file, lowercase g takes you to the beginning. And let's see, where were we? So we had, so like the text type, that's one that we seen before. So if we do slash for search, slash searches in any environment that you're in, slash text, we'll search for the text type and hit enter. And we have that the alignment over here is I for integer, and the type length is -1 for a variable length type. And we said that the The rule of thumb that you should use when you are ordering your types is that the variable length types should go at the end. You always order them from the largest fixed size type to the smallest fixed size type, and then the variable length types at the end. So all the text columns will go at the end. I'm going to see, in order to do this, let's go ahead and open up a second window down here, open it up in Vim, and then I'll type out the solution down here. So it'll be create table, public.film, something like this. And we said that the title text should go at the end. Title, text, not null. There's any of these rows, or they're structured as rows, but any of these columns in this table, they can have other things besides the name of the column and the type of the column inside of them, but none of those things matter for column Tetris. So the fact that this has not null after it will have no impact on the amount of space used by this column in any situation. And so we know that this is going to go down at the bottom. Film ID integer, so where does that go? The integer type is one of the more confusing ones. So if I do escape /int and press next to keep going to the finding the next occurrences of integer, you can see there's a lot of int things, but there's not actually going to be an integer thing like this, pattern not found, integer not found. And the int types are, or integer is actually a synonym for this int4 type. So integer equals int4, small int equals int2, and the big int equals int8. In Postgres, there's a lot of different types that have different type synonyms like this. And so if you don't find whatever the type is that you're looking for inside of this table, then you'll just have to search through the Postgres docs, find the particular type that you're looking for, and it will tell you what the name in this table is. For the most part, though, it should be, other than these integers, it should be a pretty straightforward one-to-one mapping. So the integer int4, looking it up over here, int4 size of 4. So that's going to come before the title. So film ID integer, and then I'll type out all of the other stuff as well, since that's what you should be doing on film underscore ID sequence type reg class not null. We want you doing that on the, or what this question is asking is to actually create the table with the rows in the appropriate order, or with the columns in the appropriate order. And so in order to create the table, we need the full command for creating that column. And so these first two columns are still in a good order. Then this description column right here, also text, so I don't need to look that up. Description, and then text, like that. Here the text type has a size of -1. And in general, when any two types share the same size, so here title and description both share the same size, their size is -1, it does not matter what order you put them in. The results will be exactly the same no matter what order they're in. So if you had description text followed by title, that's fine. If you had title followed by description, that would also be fine. But then this next one here, this is where the first thing we'll have to rearrange the order under release year, public.year. Let's switch back over here and try to find the year, /year. And right here we get the year type, and its size is a 4. And so because it's a fixed size 4, it must come before the variable size is text right here. And so release year public.year. And again, maybe we can make this a little bit more organized. These have length equals -1 right here. These have length equals 4 right here. So now that just helps me as I'm going through this to know that all my 4 things should go right here and my -1 things down here. This year type, not something that we went over at all in class. And it's actually not something that is built into Postgres. It's a special type for that's defined inside of the Pagilla schema. But even when you define your own custom types, they get put into this table right here, and so we can look it up that way. One of the maybe confusing things about this pager environment that we're in right here, I'm going to go to the very top right now and do a /year. /year, it will take me to the year. But if I happen to be below wherever the type is that I'm looking for, and say now do a /year, it will tell me that the pattern is not found. When you do the / in the pager environment, it only takes you to the next occurrence, not looking at previous occurrences. So if you're anywhere other than the top, anywhere other than the top and you do the search, you might not actually find it. So good practice when you're searching for the type, always just press G first, take you to the top of the pager environment, and then do the search. Let's pause here, and any questions about anything that we've seen so far? Joey?
What is the public doing?
Good question. So the question is, here, what is the public doing? And basically, why was I searching just for year and not public.year? The answer is that in Postgres, anytime you see the dot in Postgres or in any SQL variation, the thing to the left of the dot is somehow a qualification on the thing that sits to the right. So we saw this dot previously when we were using joins on tables, and we had different columns that had the same name. And the thing to the left of the dot was a table name, so that we knew exactly which column to select from. The thing in this case, to the left of the dot, is called a schema. And basically everything in Postgres is in the public schema by default. You can put things inside of other schemas if you want. And so this is actually 100% equivalent to that. There's no difference at all. This table that I got right here, I just copied and pasted from the actual Pagilla file. And so I don't know why they chose to put the public.year there, putting the public in front and for that type and not the other types. But it has no effect on anything at all. So anytime you see a dot in Postgres, you can basically just eliminate, like not consider the stuff to the left. It's only the thing to the right that matters. Good question. Yeah, Joe?
So for the midterm, will the table that we'll be doing column setters on, will that be part of Pagilla, or will it be just like a random table?
Good question. The question is, from the midterm, will the table that I give you be one of the Pagilla tables, or will it be a random table? The answer is that it could be either. And so I think one of the reasons I chose the film table for this assignment is because it is by far the most complicated table in the Pagilla database. And so if you can do this film table, then you can do any of the other tables. You should also be able to do this column Tetris with, so I gave out another handout called the tuple size notes.sql under week 5. And you should be able to do the column Tetris for all of these tables as well. These are specifically designed to showcase some like weird edge cases. And in particular, this example 4, having 9 different columns has some weirdness that can come up with that compared to the other examples that have less than 9 columns. So we can talk about why this is another important case to consider after we finish the Pagilla one. But you should be able to do this with any arbitrary table that I give you. And in particular, there will be types that we have not discussed in class in any form that you'll have to figure out using the documentation or these other resources, how to get the information for those types. Good questions. Any other questions about what we've done so far? Tom? So can you be a little bit louder? I can't hear you.
Sorry. In the next law function, yeah, where is the?
What is all of this? Good question. The question is, what is this whole next val thing? Two-part answer. The first part answer is that you don't have to know. That's one of the sort of purposes of this particular problem here is to get you just comfortable doing the column Tetris with things, columns that have properties that you don't know what they do. And so again, this has no effect on the column Tetris aspect at all. The only thing that can affect the column Tetris is the type of the column. So that's the first part of the answer, is that this is the only thing that you actually have to know. What this actually means is that this default value is going to be the next value in some particular sequence. And so any ID is going to start at 1, then 2, then 3, then 4, and so on, if you're not like manually specifying a number. It's common for IDs to have a default that has this next value right here. And we've also seen that there's this serial type, film ID serial, not null, like this. This line 5 and line 6 happen to be 100% equivalent to each other. Serial is syntactic sugar in Postgres for integer default next val, this whole thing right here. So yeah, that's what this is doing, is it's just making default values that aren't all the same for this. So yeah, when you specify default, it doesn't just have to be a constant. It can be an arbitrary function that's doing an arbitrary computation. In this case, getting you another value. Good questions. Any other questions so far? Okay, so let's do a couple more rows here to see some more interesting things happening. So so we've done up to release year here, then there's language ID and original language ID. Both of those are integers. So we've already looked up integer, int4, and so we can just straight away place them right here. Language underscore ID, integer, not null, original language ID, integer. And then we get to this rental duration right here with a small int. The small int, again, is an int2. If we look back over at our types over here, here's the int2. It has a type length of 2, hence the name. And so let's just make a new section right here with stuff with length equal 2. And then rental duration, small int, default 3, not null, like that. And let's get rid of that typo. Rental rate, this one is getting a little bit more interesting. We're getting to this numeric type. So coming back over here, /numeric. And here you can see that we have a type that's called numeric, but it doesn't have those parentheses with the numbers inside of it. It's just numeric by itself. And these parentheses over here turn out to be just sort of like special constraints. That they're numeric 4,2 is represented the exact same way internally as just a numeric by itself inside of Postgres. We could look in the documentation for the numeric type and it would tell us that. And so we just use the fact that it's a -1 to move it to the very bottom. So down here, which one? We're on rental rates. Rental rate. numeric 4,2, default 4.99, not null. And again, the reason they're using a numeric here is that they're representing money, and we don't want to use floating point numbers to represent money because no decimal number is represented exactly, or very few decimal numbers are represented exactly. Very few decimal math operations are represented exactly with floating point numbers. And so if we're storing money, we'll eventually get weird rounding errors and losing pennies and then eventually dollars. And then if we're a big bank, eventually millions of dollars due to rounding errors. And the numeric is guaranteed to always use exact arithmetic. It's slower, it uses more space because it has this variable space representation type. It potentially needs more space. The documentation goes into gory details about how it does all that, which we don't need to know. But if you are storing money, numeric is the right type to use to store money. Then there's the length, small int. Okay, we've seen small int before, so we can just do length, small int. Replacement cost, we've seen numeric before, so let's add replacement cost. Numeric 5,2, default 19.99, not null. We're almost done here. Now we're going to this rating. We have this public.mpaa rating. There's another one of these types that is defined inside of the Pagilla database. It's not built into Postgres. This is very domain-specific type being related to the MPAA here. So going over here, /MPAA, there's our MPAA rating, and turns out to be the fixed size of 4. So we'll move it up into our length equals 4 section right here. Where did it go? Rating, public.MPAA rating default G type public.MPAA rating, comma. We're almost done. Maybe I'll pause though to see if anybody has any questions at this point before finishing the last few columns. Julie? Yeah, so the question is exactly what's this rating column? Internally, it's called an enum type. Enum type. Enum stands for enumeration. And anytime you have a fixed number of things, you can, so we know that the G, it's a text, so we could represent it as text. We could represent all our ratings as text, like G, PG13, all of those things as text. But that's not very data efficient because those are the -1 size. They could be arbitrary length. It's also not very like structurally sound because somebody could like make up a PGQ99 rating and our database wouldn't catch that. And so we can define our own types using this enum, and there's only like the 5 G, PG, PG13, and so on that are listed there. Postgres will check to make sure that you're inserting a valid rating, and it's guaranteed. Internally, it's storing those as an integer, and so that's why it has size 4. The Postgres documentation actually strongly, if you were to read about the enum types, it says you should never use an enum type. The reason Postgres supports an enum type is because MySQL supports it, and they wanted to make it easy to port from MySQL databases to Postgres databases. So again, this Pagilla database started off as an example database for MySQL, and they ported it to Postgres. And so that's why there's this enum type here. But really, this would be a little bit nicer to represent it as a join between 2 other tables, where you have one table that represents all of the possible MPAA ratings, and then this is a foreign key into that table. Yeah, so that's a stylistic Postgres-y style thing, but you will see people using the enum type in Postgres too. Did that answer your question? Any other questions so far? Okay, last two or last three rows down here. We have last update, timestamp with time zone. So SQL is super weird with their types and formatting compared to other programming languages. So this, these four words right here all together constitute a single type, timestamp with time zone. Most programming languages require that you not have spaces in the names of your variables or the names of your types. But SQL and Postgres in particular don't have that requirement. And timestamp with time zone. Let's do a search for timestamp. Okay, pattern not found, but timestamp does exist. What I have to do when I get this is I press G to go to the top. Now I press slash again, up arrow to research, and there's our timestamp and timestamp TZ. If I look up at the documentation, we'll see that timestamp is shorthand for timestamp without time zone, and timestamp TZ is shorthand for timestamp with time zone. And so we have the type or the size of 8 right here. So it's the biggest thing that we've seen so far. And so that has to go at the front. Move it up to the top here. Length equals 8. And we get our, where did it go? Last underscore update. Timestamp, I'll just write timestamp TZ for short. But again, that's exactly the same as timestamp with time zone. Default now, not null. So again, here we're using an arbitrary function as our default, similar to how down here we had an arbitrary function as our default for the key, which did the auto incrementing. So there's a common default value for timestamps. In Postgres, if you read the documentation about timestamp versus timestamp TZ, they will tell you that you should never use timestamp and always use timestamp TZ. And timestamp is only included for compatibility with the SQL standard. If you use timestamp without a time zone, it will it'll just forget like where in the world the time is in reference to, and so that's not a good thing to do. Always better just to include that timestamp information, time zone information, and they both have the same exact storage requirements and other overheads. So this is a strictly superior type to timestamp. Any questions about that column? Okay, special features, text, and then an array. So one thing I don't think we talk about is that every type in Postgres has a type associated with it that starts with an underscore. So we've seen the text type before, and then there's also the underscore text type. And the underscore of a type is just the array of that type. And so anytime over here we have text square brackets, text array, that's exactly equivalent to underscore text. And it also happens to be the case that every array value can store in anywhere from 0 to an unlimited number of entries inside of it. So no matter what type you're storing in an array, its size is always going to be -1. So anytime you have an array, that's always something that you want to put at the end. So down here, special features, text like that. And then one last column, full text TS vector. Come back over here, slash TS vector. There it is, and it has a -1 length. We'll be talking about TS vectors a little bit after break. They're used for full text search in Postgres, and so we'll be talking about how that works and using these TS vectors. But for now, all we need to know is that they have the length of -1, and so they go at the end. So down here, full text, TS vector, not null like that. And then this would be a 100% full credit answer. Again, there's lots of possible variations on how you could do this. Inside of any one of these categories, the order of things can be shuffled, be rearranged. The names of types can be, there's potentially many different equivalent type names. So like instead of timestamp with time zone, you could just write timestamp TZ like this, and that's okay. It's also okay just to copy down exactly each line verbatim as it is, probably the safest thing to do in a sort of midterm sort of scenario. Any questions about that problem? Anybody? Yes, Dustin.
So on your GitHub, you display the link to a page where you can automatically calculate the order of views. And so I checked my answers to that, and for this problem, like it's not exactly the same, and I wasn't sure. Like, I mean, generally speaking, yeah, like you order the ones with the highest like the memory first, but like were they ordered in any other way as well?
So the query should have these things sort of blocked out like this in these blocks, and then inside the block, the order might be totally different. But when things have the same length, it doesn't matter what the order is. So so that query is guaranteed to give a valid answer, but there are also other valid answers. If you think it's doing something like particularly weird, I'd have to see the exact example.
I wondered if it was like sorting on anything else besides the length.
So there are things that you could potentially do to, depending on like, if you know something about what your data is going to contain, to make the rows even better than this. For the midterm, you don't have to worry about that. But the way that, that this comes up is that if something is null, then you recall that it doesn't get stored at all. That the only values that get stored are values that actually exist, and things that are null don't get stored. And so if you know things about like which things in your data are going to be null a lot, it might make sense to reorder things. Similarly, down here on the -1 length things, if you know, for example, that the description is always going to be super, super long, then for weird internal reasons, it would make sense to put that at the end. I don't think that query, though, is trying to do anything fancy like that. I think it's probably, if there's other orderings, it's just like non-determinism about how things are ordered. Yeah, again, for the purposes of the midterm, the thing that's important is just that the lengths, things are blocked into their appropriate length. Good question. Any other questions about this problem, Tom? Sorry, can you say that again?
Yeah, what does the main equal negative 1 mean? Like your column with main equal to -1?
Oh, what does this mean right here? For each one of these sort of blocks of columns, I was just putting the length as described by this column right here, this type length column. So the length equals -1. I chose -1 because that's what's appearing in the type length column over here. And what -1, the semantic meaning of that is that the length of the field will depend on the contents of the data. So like for text, that's relatively intuitive, how that depends, that if you just have more text, it takes more space to occupy. And one of the things that you'll have to be able to do for the midterm is calculate the number of bytes that a row is going to take up. But for those types of problems, you don't have to worry about these length -1 things, because the internal storage of all these sort of types is very complicated. One of the things that we mentioned about is that text types will automatically compress after a certain point. And so you don't have to ever worry about like compressing things when you store in Postgres. It will automatically do that for you. And because of that, I'm not going to give you like a string of text and ask you to run gzip compression in your head and figure out what the length of that is. When you're trying to figure out the length of the actual number of bytes that a row takes, I will only give you these fixed size values. Did that answer your question? Any other questions on this problem? Okay. Let's see, we were starting to Yeah, so what we're reviewing with this problem is particular, like the ordering of the rows, but we didn't talk about like how many bytes does the particular row take up. And that's one of the, that's what this tuple size notes.sql file is really focusing on, is how many bytes does each row take up. And I gave us a way to actually check that in Postgres. So for this example 4 right here, if we have something like this this column, well, let's start at something shorter so I can type something shorter at first. Something like this, we have just a single integer in this example 1 right here. I'm gonna, where do I have Postgres open? There we go. There was a select PG column size. PG column size can tell us how many bytes a particular row takes up. And this is a slightly confusingly named because it's called column size, but one type of a column is a row. And so the column size function can tell us how much space a row is going to take up. And on this first example 1 problem right here, we have an integer. And so one type integer. When we're doing this, we must specifically specify what the type is that we are using right here, because otherwise Postgres doesn't know how to represent this number. And I know to put an integer right here because that's what this one corresponds to in this table right here. It's an integer. And so if I hit enter, it tells me that PG column size is 28. This 28, what it is it's the sum of the header and the data portions of the row. So it is not the final answer that you would need for the midterm. Because for the midterm, there's also this padding information that we need to know. And the padding, what we have to do is we have to take the size of the row and make it divisible by 8. So here 28 is not divisible by 8. The next largest number that is divisible by 8 would be 32. So we would have to add 4 bytes of padding to get 32 here. There we go. Have to add 4 bytes of padding here, and the total row size would be 32. The tricky thing, well, yeah, there's 2 tricky things. The first tricky thing is about how the headers work. So this example 4 down here is sort of stretches or provides some edge cases about how the header works. If we recall, let's see, move that to a different screen. I'm gonna draw some stuff right here. So each row, that's not a straight line at all, but there's my row. And then it has some header at the beginning, fixed header. And that's always has, at the beginning of it, 23 bytes corresponding to this struct field. But this header must be, the final header size must also be divisible by 8. And so the minimum size that the header can ever be is 24. Min size is 24, because 24 is the next largest value after 23 that's divisible by 8. But the tricky thing about the header is when we have null values in our row. By default, the header contains no null map. If there are no null values in the row, so no null values implies no null bitmap, implies the header will always be 23, which then goes to 24. So anytime there's no null values in the row, the header will always have size 24. But when there are null values, When there are null values, then we need 1 bit per column in the null bitmap. And it's important that this is 1 bit for every single column, whether it's nullable or not nullable, whether it happens to be null or happens to not be null. And so if we ever have more than 8 columns in our row, if we have more than 8 columns in our row, then the null bitmap, well, let's start with less than or equal to 8 columns implies null bitmap less than or equal to 1 byte implies that our header of 23 plus 1 byte stays as 24 bytes. Header equals 24 bytes. But if we have, do it right down here, greater than 8 columns, then null bitmap strictly greater than 1 byte. So our header is that 23 plus the size of the null bitmap. So it'll be something bigger than 24. And so it'll have to get rounded up to the next multiple of 8, which is 32. Technically, this will be true for up to like 260 or so columns, and above that will overflow the 32, and then it'll be 40. But I guarantee on the midterm, you're not going to have a table with more than 260 columns in it. Any questions about this 24 versus this 32, that situation?
So even if they're like greater than 8 columns, that's only, it only becomes 32 if there are no values.
That's correct. So the question is, will this 32, will the size of the header only become 32 if there are null values? And that is correct, because the null bitmap only exists in the row if there is a null value. One of these, so we haven't talked in detail about what these header values are, but one of these header values is just a bit saying, is there a null value or not in this row? And if there is, that bit will be set so it knows there's going to be a null bitmap here.
And so a null value isn't, so that doesn't mean that like a column could be null in the sense that it's not specified as not null. It has to, like, you have to be inserting an actual null value.
That's correct. So the question is, well, I'll just state the answer, and that'll say what the question is as well. But so in here, in example 4, all of these columns right here are nullable columns. They could be null. In this particular row right here, there is no null value being inserted. So even though we could insert a null value, we are not inserting a null value. And so there is no null bitmap. And so the header size is 24 for this particular row. For this row right here, however, there is a null value. And so because there's a null value, we need a null bitmap. The size of this null bitmap is going to be 9 bits. That's going to overflow the 24 bytes. And so we'll jump up to 32 bytes. That's the size of our header for this one right here. And so what's sort of counterintuitive is that here we're actually like, there is more data that we want to store here than there is here. There's actually one more value here than there is here. But this row right here is going to take up more space because of that like extra overhead of the null bitmap. So the vast majority of times, having null values is going to reduce the data size of your row. But if your table happens to have more than 8 columns in it, you could potentially increase the amount of disk usage that you're using by adding a null value. that is a concept that guarantee will somehow be tested on the midterm. With this situation, when you have to go from 24 up to 32 on your header. So are there any questions about that?
Professor?
Yes.
So I was wondering, what if there was no null, and then we have like maybe 250 data? Is it gonna be still 24 bits? So instead of like in this, like an example 4, like in on line 97, we have 1 to 9. I was wondering, what if it was like 1 to maybe 250?
So the question is,
maybe
what if we
1 to
have more rows than just 9 rows here? And the answer is that it doesn't matter how many rows or how many columns we have in this row, as long as none of those columns are null, then we will not have a null bitmap.
all right.
So if we had like 10 million columns, then yeah, no null bitmap, as long as they're all not null.
And then like I just wanted to know, to make sure, like, so every time there's a null bitmap, that's when we actually consider the 8 and the 9 value. But what if there was like 2 null bitmap inside the table? No, but
so the
not
question
only
is,
one.
can there ever be 2 or more than 1 null bitmap? And the answer is no. That with when you have a single null value right here, what the null bitmap is it's a single bit, a single 1 or a 0 for each column in the table. And so here the null bitmap will be 0, 0, 1, 0, 0, 0, 0, 0, 0. So the 1 indicating that there's a null here. When we have multiple null values, the null bitmap will just, so down here, the null bitmap looks like 1s in all of these columns. So we don't need multiple null bitmaps because just one of them is enough for us to know exactly where the nulls are and are not in the row.
Okay. So for the last on line 111, that last one, is it 32 for the header?
So the question is, what is the exact size of the header on this last one? And the answer is that it is 32. The header for this one and this one are going to be the same, both 32, because they contain at least 1 null value. Having more than 1 null value will not increase the size of the header. You will see, though, that the size of the row for this one here and this one up here are different because we don't actually store data for null values. So down here, the data section is going to be 0 because there's no data to store. The only thing that we'll be storing is the header. And so we'll have header 32, data 0, 32 plus 0 divisible by 8. So padding is 0, so the total is 32. Up here, we'll have header 32, and then there are 8 of these values. They are all small ints, so they have size 2. 8 times 2 is 16, plus 32 is 48, so the size will be 48. That's divisible by 8, so the total will be 48. When I wanted to show how to check these answers, and we started doing that over here but with this row, and here I have just a single type listed. Let's go ahead and make this a small int so that it corresponds to what we see in that problem number 8. At this point, I only have 1 column that's a small int. In the problem, there are 9 columns that are a small int, so I'll have to add those other columns here in a second. But first, notice that when I had the integer, the size was 28. And then when I go down to small int, the integer had size 4, small int has size 2. So that's why the size goes down here. The ultimate total for both of these two is still going to be 32 because we must be divisible by 8 in our final size. And so we'll have to pad both of these 2 rows. The padding size will just be different. It'll be padding size 6 down here, padding size 4 up here. In order to get this 8 times, what I'm going to do a nice real quick Vim trick, \E, open up Vim, F1 to take me over to this spot right here. I'm going to yank inside the parentheses, Y, I, parenthesis, yank, insert parenthesis, copies everything, all this stuff right here into my clipboard. and then paste like that, and it pastes it all. There's no comma, so let's add a comma, and then 3, copy all of that, yank, and I want to paste it 7 more times. So, oops, 7, paste like that, and now I have my 9 columns like this. Let's do a colon WQ to save and run that, and we get size 42. So let's think about why is the size 42 here. And first, let's remind ourselves exactly what this PG column size means. It's the size of both the header plus the data. The header, again, we have no null values here. No null values, so the header is just going to be 24. And then the small int has size 2. There's 9 of these small ints, so 2 times 9 is 18. And so 24 plus 18 gives us the size of 42. It's not divisible by 8, so again, we'd have to round that up to 48 to get the final total size. But this would be getting the answer for this first problem right here. For this next problem right here, I have a single null value. So \e, reopen this up. We'll put this in the right spot, x null like that, single null value like this, save and quit. And now you can see that the size has increased, even though I added a null value. Why did the size increase? So again, this is the size of the header plus the data. The header now has size 32 instead of 24, like we talked about before. And then there are now 8 small ints that need to be stored. And so 8 times 2 is 16. And so 16 plus the 32 gives us the 48 right here. The 48 is divisible by 8, so there's no padding. And so that's what our final size is right here. So both of these two happen to have the same final size of 48, but it's due to the fact that the padding is different on the two of them. The last problem, \E, I'm going to do a find and replace in Vim :s/1/null/g. Replace all the ones with null. Save and quit. And now we get the size is 32 because there's no data being stored. This is only for the header. And that is divisible by 8, so we get just 32 for our final answer down here. I did all those problems super fast, and so if you have questions about any of those steps, that's totally reasonable, and now would be a good time to ask them. Awesome.
When you're typing in SQL with the PG column size, and for the 1:::, is that like the value?
Let's see. So I think the question's exactly what is going on with the : and so if I do something like select 1, then I get a 1 like this. Anytime you have a type that is ambiguous somehow, the : is how you specify what type you want this value to be. So I could do 1 type integer, 1 type small int, 1 type float, and get the different numeric types this way. This notation comes from math. Depending on which upper division math courses you may or may not have taken, you might not have seen this before, but if you have a value and then some colons and then a type, it's just saying this thing on to the left has the type of the thing to the right, or it's in the set of the things to the right. And so when I was running these commands up here, I had the row. So the row is converting all of this stuff right here into a single row, and the null, or the thing that's to the left of the colons, is the value. In this case, the value for all these is null. The thing to the right of the colons is the type. And so we're specifying small int. Whenever you're using this PG column size with the row function, you must specify the types of all of your columns so that they match to be whatever is the type of the table that you're sort of trying to emulate up here. So the reason I chose small int for all of these is because these are all small ints. If I was, say, doing this one up here with 3 values, it would be like 2 type big int, 3 type integer, 1 type small int. Did that answer your question, Justin? Good question. Any other questions about this problem or column tetra stuff in general? Any other questions about anything related to the midterm? Do you all feel like it's going to be easy midterm, impossible midterm, medium midterm? A couple thumbs up. A lot of mediums. Question?
For the SQL problems, were you required to do any of them a certain way?
So we've talked a lot about the last problem, problem number 5, what to expect from that, but not about the first 4 problems, the Pagilla SQL query problems. And the question that Joey asked is, well, what will the requirements be in terms of like formatting, and do you have to do them with a left join versus a subquery or anything like that? And the answer is that you should be familiar with how to use both the left join and the subquery techniques. I may or I may not require you to use a particular technique. In terms of like final formatting, I'm not going to require any sort of special formatting of like everything must be uppercase or sort of I don't know, fine-grained sort of details like that. It'll all be like big picture concepts of getting your joins correct, getting your subqueries correct, getting your where conditions correct. There might be an order by that requires you to use the ascending and the descending correctly. Yeah, there won't be any columns that I'm asking you to return. You won't have to do any sort of like operations or functions on those columns. It'll just be selecting the column straight from the table. No sort of operations on those columns. Question, Dustin?
We also consider specificness, like for example, like in question 4, Pagilla 1.3, I wasn't sure, you know, it could be solved almost strictly with a with statement. Will that also be something to consider, or is it
Great question. The question is that if there are multiple ways to solve a problem, it doesn't matter which one you choose. And the answer is that I could require you to use a with statement. I could require you to use a left join or a subquery. I could require you to use any of the techniques we've talked about. But if I don't require a particular technique, you're allowed to use whatever you want. And you can be sort of arbitrarily bad as long as you're getting the right answer and doing the right conceptual things, and you won't lose points that way. Yeah, again, the main purpose of this sort of first 3-ish weeks of SQL is just focusing on getting the correct output, understanding what the SQL is doing, and the after post-spring break part of this course will be understanding how all those differences affect performance. And so that would be something to consider on the final, but for the midterm, not going to be important. Yes?
Are you going to specify like the specific like columns we need to select? Just like
let's see. So on the Pagilla homeworks, I would occasionally give you hints about like join all of these columns together from these tables. I will not give you those hints, but for the final output, I might not say like specifically select the title column from the film table, but it'll be like just select the titles. So it'll be obvious like what columns to pick. At least last semester, nobody lost points on something like that, and I can't imagine how that would happen. If you do have like just questions like I think I understand what this problem is asking, but I'm not 100% sure. Like, so something like, what is the right column to select here? Then it would be appropriate to send me an email about that, and I may be able to answer that. But again, for the midterm, no posting issues on GitHub about things like that. Any other questions that people have? Okay, I'll be in my office and office hours, 1 to 2 p.m. again today. If people have, if you think of more questions that you would like to get answered, then please stop on by. And then after office hours, so basically after you have lost your final chance to ask questions, I'll post the midterm and I'll make an announcement on the GitHub issues when I do that. And then you'll have until Friday at midnight to complete it. Okay, so yes, good luck. Enjoy your all's spring break. Maybe another reminder that there is a homework assignment that'll be due at the end of spring break. So for me, I would get that done before spring break, but you're welcome to do it whenever you'd like. And I guess on that homework assignment too, if you do collaborate, you have the additional 48-hour extension. So you could wait until after spring break, collaborate with people and finish it up on Monday or Tuesday, and that would be fine too. But I hope you all have a good spring break and a good luck on the midterm.